screen. Okay, so the first thing we're going to start with, today we're focusing on the Pythagorean theorem. Okay, and some people are like, what is a theorem? Okay, a theorem is actually a statement, like a mathematical statement that someone proved was true. So Pythagorean theorem was actually found true by Pythagoras, like way back in the day. Fun fact, there was a Babylonian tablet that was discovered like this. I think it was discovered a couple years ago, but this past summer, they actually were able to translate it and found that the Babylonians were using the Pythagorean theorem thousands of years before Pythagoras was even alive. So there's a chance that in the future, they might even change the name of this theorem, since technically it was around before Pythagoras. But anyway, one of the best known theorems in geometry is the Pythagorean theorem. If you talk to somebody and you mention the Pythagorean theorem, even if they are an adult, they can probably tell you a squared plus b squared equals c squared. It is the formula for the Pythagorean theorem. We're going to talk about what that even means and how to calculate it, but most people who have gone through schooling do remember that equation. So this is the technical definition of the Pythagorean theorem. When you write that statement down, the square on the hypotenuse of a right triangle has an area equal to the combined areas of the squares on the other two sides. That might not make sense to you right now. That's okay. There's words in that statement that you don't know yet, and that's okay. But I also want you to draw the picture, just a little sketch. When you're learning the Pythagorean theorem, sometimes the visual is easier to see than the words. So write down that statement. Just the red. But also sketch that triangle. It doesn't need to be perfect. But I'd like for you to label the triangle. Has an area equal to the combined sides of the combined areas. So when you label this, what we're really focusing on is this triangle. What do you notice about this triangle? What's that little symbol?
Right.
It's a right. It's a right triangle. And there's three components of a right triangle in terms of the sides. We have two of the sides are called legs. And then we have the hypotenuse. Now we know a few things about the hypotenuse, which we will cover at other times, but I'll start to go over them now. The hypotenuse is the longest side. So it's the longest side. And in terms of its location, it is always opposite the right angle. Or across from the right angle. I'm sorry? Yeah, that's what we would label. So if you think about what makes up a right triangle, the right angle is actually made by the two legs. And then the side that's opposite that angle or across from it is the hypotenuse. So the Pythagorean theorem, and again, this is a very technical statement. We're going to break it down so that it's a little bit more understandable, I should say. But notice what we have. What we do to create a proof of the Pythagorean theorem, we have squares. And we're going to use these squares. And actually, in the next couple of weeks, we're going to prove this theorem is true with a visual. We're actually going to use paper and kind of prove it. So again, the square on the hypotenuse of a right triangle has an area that is equal to the combined areas here. So really what that means is the area of this square is equal to this square plus this square. Always. In a right triangle, it is always true. Did everyone write that?
What the labels around?
Leg, hypotenuse.
Leg.
Okay.
Which ones are the legs? Those small squares?
So the legs are the two shortest sides. They are the two sides of the triangle that form the right angle. So those are the legs. The hypotenuse is the longest side of the triangle. Some triangles, it's hard to tell. But you can always find the hypotenuse because it's directly across from the right angle. And I would say to rely on that, because I've had students in the past assume that a side is the hypotenuse, because they just think that it looks bigger, but make sure the location of it is precise, that it's across from the right angle.
What did I say in black?
Oh, the hypotenuse, we're going to go over this again, so you don't have to write it right now. The hypotenuse is always opposite the right angle, and it's always the longest side. Okay, so this is the last thing that you're going to write in terms of definition. Okay? This is another way of stating the Pythagorean theorem. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. That's the last definition you'll write. And after you write that definition down, you're going to write the actual formula. The formula for the Pythagorean theorem is a squared plus b squared equals c squared. Now in terms of the labels, c represents the hypotenuse, always. So it's
okay, so why would you use Pythagorean?
as you're writing down, if you have questions, we're going to dive, this whole unit is the Pythagorean theorem. So we're going to spend a few weeks on this, on how to calculate it and how to find the lengths of the triangles. There are a ton of real application. There is a ton of real application for the Pythagorean theorem. So over the next couple weeks, I'm going to show you in sports. The Pythagorean theorem is actually really, really common in sports. It's very common in building. Any type of construction utilizes the Pythagorean theorem. I have a friend who served in the Army, and they were actually conducting a raid in Afghanistan, and they used the Pythagorean theorem to set up an IED. They knew how to plant it based on, and he spoke to one of my classes, and if I can get him to speak to you guys, I'll have him do that. But he explained how they actually used the Pythagorean theorem because his group was here and the enemies were here and they were going that direction, so they actually used the Pythagorean theorem to cut them off when they conducted their raid. It was really interesting when he explained that because so many people say, like, when would you ever use this in real life? And there are a lot of examples. So I'll be showing you over the next couple of weeks all the different ways that the Pythagorean theorem is used in the real world. So the formula here is that you're going to, and you'll see as we start to break this down, find the square of both sides, both legs, okay, and add them together. And it will always equal the square of the hypotenuse. So the formula is a squared plus b squared equals c squared. There's two ways we can prove the Pythagorean theorem, and we're going to start to focus on them on Wednesday of next week. Today we're just going to learn the basis of it, and we're going to work with a couple calculations to figure it out. These are very technical definitions. If they still confuse you, don't worry. You're not going to have to restate them on an exam. As long as you understand how to calculate the Pythagorean theorem, you'll be okay. The labels are more important to know that a squared plus b squared equals c squared. That's really the formula that we're going to use. Now, I give that formula to you up front, but we're going to spend the next few days in class actually proving that this is true. Before I slide over, does anyone need more time writing? Okay. I know it's a lot of writing.
Are there any more rules to it? It's just that standard.
Yep, that equation is used. Now, you'll see it in a few different formats. Maybe sometimes you'll be given the two legs and you have to find the hypotenuse. Maybe other times you'll be given the hypotenuse and one of the legs, and you'll need to find the other leg. You can use the Pythagorean theorem on a graph and actually find the distance between 2 points. That's really the entire unit. It's a fun topic. Okay, I'm going to slide. Right, so we can use a diagram here, and you don't have to draw this visual, but I just want to show you, if we have this triangle here, this side, this leg is actually 3 units long. You can see that image. This unit here is 4 units long. You can see it on the image. And here, this is 5 units long. If I calculated this leg squared, 3 squared is 9. That's why we actually have a square here. So this is 9. This side is 4, so 4 squared makes 16. And 9 plus 16 equals 25, which is the hypotenuse squared, 5 squared. That will always happen. Okay, so that's how you can actually show it visually. So if you had to teach, if you had to explain this to somebody over the phone, how would you explain how to locate the legs and the hypotenuse? Like if I'm looking at a right triangle, it's not always going to be like this shape. Maybe sometimes it's going to look like this. Right? Maybe sometimes like this. Maybe sometimes like this. How would you explain how to find it? I can't just assume. I can't just assume that like the one that I drew in class, the hypotenuse was up here, so this has to be the hypotenuse, right? Is this the hypotenuse of this triangle?
No.
No, how do you know that? It's a bad triangle sketch, but how do you know that that's not the hypotenuse?
Because
The right angle is
Because it's making the right angle, exactly. And where would I find the hypotenuse?
Opposite.
Opposite. So if I had my triangle here, that's the hypotenuse. In this triangle here, that's the hypotenuse. And in this triangle here, that would be the hypotenuse. Good. So once you've found the hypotenuse, you've pretty much found it all, because if you know the hypotenuse, then the other 2 sides have to be what?
Legs.
They have to be the legs, exactly. Good. How would you explain this to somebody if they weren't here? Now that you actually have classmates that aren't here. Granted, we are recording this, so they could always watch it. But just the basis of what you've written down, how would you explain this in your terminology? Because you wrote down 2 definitions, which are very technical. How would you explain it to someone? Go ahead.
I would say if you draw a right triangle, the angle, there are 2 sides that make up the right angle, the
Okay.
legs,
Okay.
and then the other side that across from the right angle would be the hypotenuse.
Okay. Okay. Now let's keep going. Michael explained the terminology of our triangle. How can we keep going with the actual theorem?
To explain it to them.
Yeah. Go ahead.
The 2 legs, they will always equal the hypotenuse.
Just the lengths of them?
No, the area.
Okay, so explain the area.
The area would be them both squared.
Okay, so like the leg times the leg. So this times itself. Or squared. And then the leg squared. Together equals
Hypotenuse squared.
hypotenuse squared. Good. So to prove that a theorem is true, like to actually prove it, we need to find a way to show that if a triangle does have a 90-degree angle, no matter what the lengths of the legs are, the 2 legs squared would always equal the hypotenuse squared. So there's a few ways we can prove this. Next week, we're going to go over 2 ways to prove the Pythagorean theorem. The one on the left here, we're going to actually use algebra to prove it, because we can use equations to prove it. Your head should be off the desk. We can use algebra to prove the Pythagorean theorem. Okay? But you could also actually use an area model. You can use geometry to prove this geometric proof. Okay? If you want to prove that something is false, like say we decided that we were going to spend our life, and there are some people who do this, they're going to spend their life working at proving that Pythagoras was wrong, that this doesn't always work. How many times do we have to find, how many examples do we have to find of the Pythagorean theorem not being true in order to disprove his entire life's work?
A lot.
Oh, wow, we just have to keep finding examples? So Pythagoras says that like no matter what, a squared plus b squared will equal c squared. If we wanted to prove him wrong, how many examples do we have to find where it doesn't work? Yeah, just one, right? So only one. Now think about this. There are people who spend their whole life, their entire lives, with all different types of right triangles, trying to just find one example where this is not true, and it has yet to be done. So, do we need to show that like every example works, or is it okay to show like, okay, this worked one time, and then it worked a second time, and it worked a third time? How many examples do you think we need to look at to say, okay, this guy was right, like it does work every time? 10, okay. Does it have to be millions?
No.
No, maybe after a handful you could say like, all right, this guy knows what he's talking about. It's worked however many times, maybe 10 times, maybe even 3 times, 4 times, however you feel comfortable. But there are people who have done this their whole life. Okay, we're going to do a little activity. I'm actually going to skip through this. And you're going to prove, using 6 triangles, that the Pythagorean theorem really does work. Okay? So, you are going to get, and once I explain this, I'm actually going to stop the recording because there's no sense in me recording sound when you're cutting paper and creating triangles. So, all of you are going to get one piece of graph paper that looks like this. You are going to cut, because I'm going to bring scissors around, you're going to cut one strip of the graph paper, and it's going to serve as your ruler. Okay, so I'm going to cut like 2 squares, like this. I'm going to cut the whole side of the paper like that. Now, the reason I'm doing that, this serves as a ruler because each square is like a unit. Okay. Once you do that, you're going to draw 6 triangles of all different shapes. But they have to be right triangles, because we're only working today with right triangles. So actually, let me add that here. How can I draw a right triangle on graph paper? Like, what's going to make that easier for me? What should I do with the graph paper if I'm drawing right triangles? Yeah, I can actually use the lines of the graph paper. Good. Once you draw your 6 right triangles, you're going to label the legs and the hypotenuse. You have enough information in your notes at this point to identify what's the hypotenuse and what are the legs. From there, you're going to create this table. Now, for some students who have done this in the past, they've done 6 triangles just on the front. Some have done smaller triangles on the front and added the table. This table, I will say, this is my 3rd year doing this activity. This table has been something that most of my students in the past have gone back to figure out the calculations of the Pythagorean theorem. So this is something that you may want to keep. You're going to create this table in your notes. What this table does, you are going to fill in the measurements for A and B. Okay. Which means you can then calculate, so you're going to fill this in and this in because you're measuring. Okay, only the legs at first. Then you're going to use the calculators that you have, and you're going to multiply to find a squared and b squared. You're going to calculate these. From there, you can add these together. And what we're going to do is you're going to use that little strip of graph paper to prove that your hypotenuse really is the length that the calculation says it is. And we'll go through some examples of this as you're drawing. I can even do an example on the board. The first thing I'm going to do is I'm going to hand you out the graph paper, and you're going to cut these little strips. And I'm going to give you some scissors. Karime, can you do me a favor and just give everybody one piece of this graph paper? Thank you.